double check right now. Since the recorder has started, I'm going to start the lecture. The homework assignment is due. Okay, so what do you guys think about the homework assignment?
That was pretty fun.
That was fun. Okay, so that's, which means it's doable. It's a little bit challenging, but it's doable. It's not mundane, and it's not a whole lot of chore either. That homework assignment. My homework assignments tend not to be, of any chore nature. Like there's a lot of repetitive, just a whole bunch of typing, because I hated that too. When I got homework assignments that is mostly chore, I go like, ugh, not that. So what we'll do today is I will talk about the solution to the homework assignment, but that will be done in the lab time. So I'll be writing the program on the fly during the lab time, starting at about 10:30. Okay. So what we'll do during the lecture time is to explain a new homework assignment that is based on the previous homework assignment. And we'll also continue to talk about string functions. Okay, so we'll talk about some kind of more interesting string functions, like one that can find a substring and stuff like that. So first of all, we'll talk about the final exam, or the exam number 2. All 5 questions are now graded, so you can find your grade online. And according to some people, I have, at least at this point, mistakenly, taken out the lowest score of the 5. Okay, I have not decided yet whether to keep that setting or not, but that was not intended. Okay, it was just that Moodle, for whatever reason, misunderstood that I wanted to drop the lowest score out of 5. Might have done that last semester and it kept the settings. So we'll take a look. I'll reset it not to drop the lowest score of the 5. Look at the scores of the whole class, see how it distributes, and then decide from that to see how I want to do it. Okay. So, are there any questions about the mastermind program? No questions? Okay. So it took a little bit of time, I guess, to get it working, to kind of understand the nature of the problem and to get it working. So what we'll do today is we'll talk about the new homework assignment that is based on the other one. And you cannot see it just yet, so I'm going to change it so that you can see it. So this way you can either look at the screen or you can look at your own screen when you have your link pointed to it. So let me just go to the common module setting, change it back to show, save and display, and now you should be able to see the homework assignment on your end. Okay. All right. So the name of this game, or the name of this homework assignment, is not Mastermind Scoring, it is Mastermind Playing. In other words, we are actually going to play the game where the computer is the one that is hiding the pattern and you are the one who's going to do the guessing, okay? Which is the easier one of the two because, if we have enough time in this semester, which I think we do, we'll also play it the other way. So you'll be the one hiding the pattern and you let the computer figure out what your hidden pattern is, okay? That seems a lot harder, but it's not, okay? So we'll talk about why I said it is not really that hard for the computer to guess it. So for this particular homework assignment, we have, okay, I have to change this a little bit. So I'm going to be changing the text as we go along. So I just spotted something I need to change. Sorry about this. Because it's based on the previous homework assignment and I forgot to change some of the names. So there will be 3 source files. There will be main.cpp, there will be mmgame.cpp, and also mm.cpp, along with all the other header files. So I'll just kind of say here, and the header files. There we go. For the homework, for this particular homework assignment, what the program does is going to randomly generate a hidden pattern, and you will have to guess it based on the feedback from the program before you run out of guesses. Okay, so it really is just like playing the mastermind game, except you're now writing the code that will do the scoring and also keep track of the game for you. Are there any questions about that part?
Is there going to be a certain number of tries?
Say again?
Is there going to be a certain number of numbers of tries?
Yep. So I'll explain that when we get to the header file. The header file will give you the constants that you need to get that part working. So a quick introduction, this part is the same. I just repeated the same information. This part is a little bit different, how to structure your code. reuse the header file mm.h. This file defines the necessary constants and structures of a guess. Okay, so that part you can keep. You can either reuse your own mm.cpp file, or you can borrow my solution. I will talk about my solution at about 10:30, okay, during the lab time. So at that point, if you want to borrow my solution, you're more than welcome to use the source code that I come up with at that point. Otherwise, if you feel that, hey, my code works just as well, you can keep using your own code as well. So that's your choice, okay? That is your choice to either reuse your own code or to use my solution. The new part of this homework assignment is the implementation of a game. So instead of just scoring, instead of just scoring individual guesses, what we'll do is we'll keep track of an actual game. Okay, so we'll keep track of the hidden part. We'll keep track of the number of guesses done so far, and so on. Okay, so we'll be doing that in an array. This part here looks like gibberish because at this point I have not switched it back to the display mode yet. So it's time to I'm going to save it and display in the proper way. So I'm giving you the content of a new header file. The new header file is called mmgame.h. The game is actually should be uppercase, so fix that to uppercase mm, uppercase g, ame.h. And the content of this particular header file is already defined here. It has about the same structure as the other one. It has a pound if ndev mmgame_h, all in uppercase. This is a macro, just to make sure that this header file is not pound included multiple times and have multiple definitions of the stuff that is inside. Okay, so together, line 2, line 3, and line 22, they work together to make sure that you're not redefining the same structure over and over again. Because when you pound include this file, those constructs will basically say, oh, don't look at the content, the rest of this file, because it has been pound included already in the past. Okay, pound ndev is basically saying pound if not defined. So this is basically saying if mmgame_h as a macro is not defined yet, then go ahead and do everything between line 3 and all the way up to line 22. On the other hand, if this is the second time you pound include this particular header file, then mmgame_h would have been defined already as a macro. If it is already defined, then it's going to skip all the way to the pound nif and not to pass anything in between to the C compiler. So that's how this particular mechanism works. You will see this type of mechanism in just about any header file for C and C++. So this is a fairly industry standard way of arranging a header file. Line 4 is not really surprising because the game of a game of mastermind depends on other things that are related to mastermind, including how we define a guess, the other constants, and so on. But we do need an additional definition, which is the length of a game in number of guesses. So the way it is defined here is, a game allows you to guess 8 times. Now I have talked to several people, and some people said they can consistently get to the answer in about 5 to 6 guesses. So 8 guesses should be doable when there are only 6 different colors. Here we have a new structure. Okay, in the previous program we have struct guess, which is still useful in this particular program, but this time we have another structure that is defining or that is representing what a game is in mastermind. And in this particular structure we have 3 members. The first member is hidden, which is really just an array of integers to store the hidden pattern, which is not really surprising because in order for the computer to hide the pattern from you and score your guesses, it needs to keep track of what is the hidden pattern. Okay. The next one is guesses used. It is a counter. In other words, this number should be reset to 0 to begin with because at the very beginning part of a game, none of the guesses has been used. But as the end user plays the game, this number will increment each time when it is presented, hey, this is the new guess, do something about it. Okay? And then we have the next member, which is an array. The name of the member is guesses, and it is just really an array of structures. It is an array of guess structures, and the length of the array is game length, which is defined on line 5. Okay, and the subroutines that you write will have to make use of game length as well. We'll describe it. We'll talk about that later. Are there any questions up to line 11 of this header file? Go ahead.
So we should have 3 files: main.cpp, mmgame.cpp, and mmm.cpp.
You should have 5 files. You should have mm.h, mm.cpp from the previous homework assignment, mmgame.cpp, which is the main file that you have to edit, mmgame.h, which is what I'm describing here, and then you still have main.cpp, because you still need main.cpp to kind of tie everything together.
That's it.
So you should have 5 files as source files. Then you have the Makefile. Okay, you can reuse the Makefile from last time. You just have to add 1 entry to it, and everything else would work with the previous Makefile. And then when you are testing your program, you will have 2.0 files or 3.0 files. One is mm.o, one is mmgame.o, and one is main.o. And then you have the executable that you're actually going to run to debug your program. So all of those are files that you might find in the folder. But in terms of source file, there are only 5. And in terms of files that I need for grading this homework assignment, there's only 1. I'll describe that later. Okay. Are there any other questions up to line 11? Well, I guess there was a question, but it's not exactly related to up to line 11 here.
All right.
That's okay, not a problem. We'll address those questions as they come up. Line 12 is wrapped around a little bit. Okay, the comment is a little bit too long, and so it wrapped around. So this one is just to generate a hidden pattern. Okay, and I will talk about how to use a random number generator in C and C++. It's not hard, it's really kind of easy to do. And if you don't give it a different seed every single time, you can actually, it will give you the same sequence of so-called random numbers, which is useful when you're testing the program. Okay, because when you're testing the program, you want to use exactly the same pattern every single time, just so that you know the behavior of the program should be this way and this way and this way. Line 13 defines another prototype, which is game reset. The only thing it should do is to reset the counter, which is known as guesses used. Okay, so that's the only thing it has to do, is to reset a member of the structure pointed to by PG. Most of the logic that you have to deal with is in this particular function, game guess. This is how we process a particular guess presented to the computer. So that's why it has 2 parameters instead of 1. The first parameter is a pointer to a game, because you're going to change some properties of the game itself. The second one is a pointer to a guess, which is a new guess, and so like, okay, the end user has entered this as a guess. What should we do about it? Okay, so that's why we have 2 structures, or pointers to 2 different structures here. So the main description is to enter and score a guess in the game. So the first thing you have to do, I'm just going to read the comments here. So the first thing you have to do is to check to see all of the guesses are used up. In other words, you have to check the number in guesses used and compare that to the length of the game. Is that okay so far? If it is at least the the length of the game, which it should not exceed, if it does equal to the length of the game, then there's nothing else to do. Just return a value of 2 and say, there are no more guesses available. This is it. Okay. If there's still room for another guess, what you want to do is you want to score the guess pointed to by P guess. So reuse what is the name of the function that we did before? Was it score? Okay, so you basically just reuse score on the guess structure first, and then what you want to do is to copy that to the appropriate entry in the array that keeps track of all the previous guesses. And I think that would, if you just look up the definition, it will be the array called guesses. Okay. Then the next thing we do, scroll up, on line 19 is the number, the counter guesses used should be updated. You should increase it by 1 because there's one more guess in the system now. If the guess pointed to by pguess matches the hidden pattern, return a value of 1. Otherwise, you want to return a value of 0. Are we still doing okay so far? So you basically have 3 possible values to return. 0 if there's more room for this particular guess and it does not match. If it does match, then you return a value of 1. If you're out of room for another guess, then you return a value of 2. Are there any questions about when to return a value of 0, 1, and 2?
When we say that again, when we return the value of 2.
You return a value of 2 when all the guesses are used up already. So there's no room for another guess. So that means this game does not give you, the right message at the right time. So the last guess, is going to, it will just complain and go like, oh, okay, you just ran out of room to have another guess after the guess is done. But that's okay. That's the behavior expected at this point of this particular program. All right. So this is okay. First, you have to define the new functions in a new file called mmgame.cpp. So this is going to be most of your code. This is okay. In fact, I'll change my way to say it. This is the only file where you will be doing changes. It's mmgame.cpp. The rest of the files are basically is once you create those files, you don't have to change them. In the main of I have to change this part too because I have to refer to mmgame.h and not just mm.h. Call the functions. So these are the functions. I'll explain how this works first and then go back and change it. So the first thing I do in the main program is I reset the game itself so that the number of guesses at this point would be 0. And then what I do is I will generate a hidden pattern. Okay, so this is the next call. And then the next one is a loop, and this one looks kind of strange, okay, because it's a comma separated expression, which means the first part does not affect the value of the expression itself. So the first thing it does is to ask the end user to enter a particular guess, and this is just a function from from the homework assignment due today. The second thing it will do is to call mmGameGuess. So it will pass the address of a guess and the address of a game to the function. The function will return the value, which I store into result. This entire assignment statement will give me a value. That particular value will be compared to 0. If it is 0, it means there's still room for this particular guess, but the end user has not guessed the actual pattern yet. If that is the case, it will just print the score. It will just say, okay, this is the score of this particular guess, and prompt the user to enter a guess again. When it does exit the loop, when do you think it's going to exit the loop? How do I get to line 15 and so and on?
When we run out of guesses.
Sorry?
When we run out of the guesses.
Well, there are 2 reasons, right? The end user either has guessed the pattern correctly or run out of guesses. Okay, so both of those are reasons to get out of the loop. And that's why after the loop, I have 2 conditional statements here to basically say, okay, how did I get out of the loop? If result is 1, it means the end user has guessed the actual pattern. So it would just say, good job. On line 18, it will check for the second condition. When the result is 2, it means the end user has run out of number of guesses. And it just says something like, try again to be encouraging. So the end user will run the program again and hopefully get it right this time. That's it. That's the entire program. So before we go any further, I'm going to fix the program itself just so that we can get a good starting point here. It's in main, so instead of pound including mm.h, it should be pound including mmgame.h, and I think there's another place where I use mmgame.h as all lowercase. I will fix that as well. Mmgame. There we go. So we're going to change this one to uppercase as well. So this way the documentation of the homework assignment is at least self-consistent. we go. So are there any questions at this point? If I were to let you guys, do the homework assignment at this point and say, I'm done describing the homework assignment, would you have any questions?
How do we generate?
Random numbers, right? Okay, so the random number thing is the first thing that you should think about is, well, how do we, generate random numbers? There are several ways to do it, okay, when you want to generate random numbers. It all depends on, how much work you want to kind of go through, okay? So we'll go ahead and, find out, how do we locate functions that has to do with random numbers. If you have a somewhat, standard Linux or Unix systems, the man pages or the manual pages actually contain documentation of all the C libraries that are commonly used. Okay, so one thing you really need to know as a developer, okay, is to learn how to use the manual page utility. Now, if you just say man random, okay, it will only find a function or a family of functions that actually has the name of random. On the other hand, there's another way to use man. If you do a -k, then it will basically say, okay, give me a list of all the manual topics that has random as a part of the description. Now this can be very handy sometimes. So I'm just gonna show you what this will return here. I'm gonna pipe it to less. The bar, the vertical bar is called pipe. It is piped to less so that I can display like one page at a time and not scroll the whole thing through before we have a chance to read it. Yeah, nothing appropriate. That is strange. Okay, so in this case, we actually have found the appropriate function to do it. It's called random, and it returns a long integer. A long integer is just a long integer. It is not a regular integer. In a 32-bit system, which we are all using the virtual machine, a long integer is 64-bit. Okay, so you have to cast the end result back into an integer. Okay, so here's the question. Given that a random number is always returning a long integer, how do we get it into the range that we want? In other words, this random is always going to return a bit pattern that is from 0 up to about, well, that's a huge number because it's one followed by, it's 63 ones as a binary number. So that's going to be a pretty huge number. So the question is, how do we get it down to the size that we want? Yep.
Would we want to typecast it? Would we want to typecast it?
You can typecast it, but if you typecast it even to an int, it will still be up to 2 billion something, right? And that is still exceeding the range that we want. So what is the range that we want? Yep.
Aren't we going to use modulus?
Yep. Modulus is the right way to do it. Okay. Do a mod first, and then have the type automatically cast it down to the right size of integer, and that will do it. So what I'll do is I'm going to write a program just to illustrate how to use the random number generator, just so that you guys can use that as a basis of your particular function. But before we move on, okay, I have made this mistake several times, is I'll just kind of go ahead and read the actual documentation, because sometimes when I do not read the documentation, it is lead to unexpected results. Okay, so here's the actual description. The random function uses a non-linear additive feedback random number generator, employing a default table of size 31 long integers to return successive pseudo-random numbers, yada yada yada. Well, it just basically says it returns some random numbers. And the random numbers, the period of this random number generator is very large, approximately 16 times 2 to the power of 31 minus 1. So that would make it, 2 to the power of 31 is about 2 billion. So this is about 32 billion-ish, okay? What that means is there's no such thing as random, okay? That's actually unfortunate, okay? In terms of certain types of computer problems, you want true randomness and not what they call pseudo-randomness, okay? The reason why true randomness is useful is so that people cannot predict the next number. Okay, think about it this way. Sorry, we cannot have a soft drink during class. Okay, so think about it this way. Let's say you are writing a program, that is a online casino type of application. Okay, and the random number generator that you are using is not exactly true random. And it has a very short period, which means it's going to reuse the same number pattern over and over again within, let's say, 4,000-ish items. So what people can do is now they can try to predict the next number. They can predict what is going to be the next card that's going to be dealt. They can predict, the next, when you play roulette, they can expect, when the what is the position of the ball, for that particular game. So now you have a problem. And having a really large, period means even though people understand it's going to repeat, it will take so long that, and if you don't know what is the current starting point or what is the current point in the entire cycle, you cannot quite easily predict what is the next number. There will be like multiple numbers that can be the next one. And that's why, you want to have a long period instead of a short period in this case. As random function sets its argument to the seed for a new sequence of pseudo-random number to be returned by random, what this means is if you do not call as random, it's going to give you the same sequence over and over again. The first number is always going to be this, the next number is always going to be that, and so on. I would suggest you to use this, at least at the beginning of your entire program, just so that it's easier to debug your program. Now, as you progress and you go like, I'm pretty sure the program is working 100%, and I just want to have fun with this program, so I don't know exactly what is the pattern to be guessed, then you can use srandom to initialize the seed so that you can end up with a different sequence. The init state function allows a state array to be initialized. We're not going to bother with that one. Okay, return value. This is the important part too. The random function returns a value between 0 and rand max. Okay, and we really don't need to know what rand max is as long as it is non-negative, because what we need to do is to wrap everything into the 6 integers or whatever maximum number of colors that we choose to use. Are we still doing okay so far with this code? Sort of? Okay. All right, so the only function that you are required to use is random itself. You do not need to use srandom. Okay, you can use srandom if you want to just kind of have fun with your program. But when I grade your program, I'm going to have to turn that off. Just so that when I test your program, I can. Well, I suppose I don't have to. I can actually write my program to guess correctly based on the feedback of your program. So we'll have 2 programs playing mastermind deal with each other. I think I'll do that, okay? So that you guys can use srandom as much as you want, and I'll make my program correspond to that. And that would be a good way to do it. Just so that I have something to do too, because otherwise, my script, my grading script would be kind of too easy to write. Okay, there we go. All right, so let's go ahead and write a few subroutines, or a few programs that make use of random itself. And one thing I forgot to do was to find out what is the header file that I need to include. It's stdlib, which is standard library. Okay, when you look at this name here, it means standard library. So we'll go ahead and write a program to make use of this. So random.cpp, stdlib, and depending on how we want to run the program, I can either use printf and whatnot, but I'm going to show you a way to debug a program without using printf whatsoever, but you'll still be able to look at the numbers generated by the random number thing. So we'll have a int random number. Okay, I don't need to write the program this way, but I'm going to write it this way just so that we have a variable to kind of look into. This is going to be an infinite loop, okay? Because the condition of a while is a stay in loop condition. One is non-zero, which is true. So this is basically saying, as long as true is true, stay in the loop. When do you think true becomes false? Never. So when are we going to get out of the loop? Never. So this is one way to define an infinite loop. For those of you who say, but that's way too many characters to type, there's a shorter way to define an infinite loop, but not by much. It is for that. Okay? That's also another way to specify an infinite loop where it is understood by the C compiler that if you do not specify the stay in loop condition, it is by default true. Okay, so this is a shorthand to write an infinite loop, which is about the same as while one. Okay, if you count the number of times you have to type, it's not really off by much. I think they're about the same. In fact, let me just double check on that. Yeah, about the same. If I put a space here, the while approach is one character more than the other one. But both are considered infinite loops. So this is going to be an infinite loop program, and all it's going to do is to do something like this: random number equals random. That's it. But we're going to do something a little, well, let's do this first, and then we'll figure out a way to kind of make sure the random number stays within a certain range, okay? So we'll first take a look at this code and find out what it's going to do. Are there any questions? Yep, go ahead.
Can you explain a little bit about the header file?
The header file? The mechanism itself, or why we are currently including standard library? Because without this, the compiler would not know what is the correct way to use random. The fact that random returns a long integer is a part of the header file's definition. So the header file includes what we call the prototype of a function, and the prototype of a function is not the definition of the function. It does not actually tell you how it is done, but it shows you how a subroutine should be used from the consumer perspective. So in this case, it shows that random as a subroutine returns a long integer. And once the compiler understands random returns a long integer and random number is just an integer, then it knows that it has to do a conversion of the type so that you can go from a long integer to a regular integer. Okay. Now, just to show you the full content of random, it is probably better just to convert random number to long int as well, just so that we can see what kind of number it is returning. And then people will say, but this program does not really print anything. Well, that's okay because we can do it in GDB. But it's going to be a hassle if we have to stop on line 9 every single time and having to print out something manually. Yep, go ahead.
Why did you change the random number to long?
Because I want to show you the entire number. Because the entire number is going to be larger than an integer.
Oh, okay.
So this will show you how big of a number it's going to return. It's going to be more than 2 billion in general. Okay? All right. So let's go ahead and compile this program, G++. And since this is the only source file, I'm not going to break it up into compiling and linking. But when you're dealing with your program, since you have 3 source files now, I really want you to use the Makefile to avoid any problem that can be the result of only compiling but not linking, or only linking without compiling, that sort of thing. So we'll just go ahead and compile this program, and then we'll run it. If you run it by itself, it's going to do this. Okay, it's going to take up 100% of processing time and just keep updating the internal variable. But since I don't have any printfs, we really don't know what it's doing. So it's not really helpful. So what we'll do instead is we'll run it in GDB and go ahead and run the program. And once again, it doesn't seem to be doing anything because it is in a tight loop. So one way to do this is to single steps. Well, it's single stepping in random right now. So I'm gonna, this is random.c and not random.cpp. So what we want to do is to list our own program, put a breakpoint on line 9, run it all the way, continue to line 9, and you'll do something about this and say print random number. Okay, there we go. Okay, it's a pretty huge number. Is it more than 2 billion? If you count the number of zeros. 3, 6, 9, this one does not. So if we run it again, print random number again. How about this one? I think this one is still not more than 2 billion. Continue, print. Okay, this one is 1.5 billion, I think. 1, 2, 3, this is 1.5-ish billion. But this is really kind of cumbersome because I have to continue and then print, continue and print, continue and print. There's another feature in GDB where anytime a particular variable is changed, it will display something to you. Okay? and I think it's called trace. So let me say help trace. Okay, set a trace point at a specified line or function. That may not be the one that I want to use. Okay, so let's just say help. Look at all the topics that can be helped here. Examining data. So I think data is the first one I would pick. And trace points would be the other one. Okay, so now we have a whole bunch of it's not one of the set commands, I know for sure, so we'll skip all of these. Specify the action to be taken at a trace point to collect, and I think I know what it is now. It's watch. There we go. Set a watch point for an expression. A watch point stops execution of your program whenever the value of an expression changes. So you can say, in this case, you can say watch random number. Okay? Because it can be any expression, right? 1 is an expression, 0 is an expression. Random number as a variable is an expression. It's a very simple one, but nonetheless it is an expression. So now we can say watch random number. So now it would basically say, okay, anytime random number as a variable is altered, is changed, we are going to stop. Okay, so we'll continue execution, and it stops, and it prints even what was the old value, and it is now updated to a new value. So this is a really useful feature, because what you can do now is to set up all of these watch points, so that whenever you debug your program, I can actually I can get rid of the breakpoint now. So I'm going to do a D1 to delete the breakpoint, because that's not necessary anymore. So you can now see how it is changing, and I think all of these numbers are staying below 2 billion. So it does return just up to 2 billion as a maximum number, because otherwise we would have seen something that is more than 2 billion already. Okay. Are there any questions at this point about this program?
You have multiple watch points?
You can have multiple watch points, but the number of watch points that are possible is dependent on the hardware, because you can see it's a hardware watch point, which means it's relying on the feature of the i386 processor to basically say, okay, if anything happens to this particular address, alert the processor and stop execution. So that's how it works, with a hardware watch point. The other way to do this is to use a software watch point, but that's very compute intensive, and usually people don't want to do it. That's a good question. I do not know the number of watch points you can actually set up. So you can see, you can basically say watch another one. You can say watch, I don't know, random number times 23, right? I mean, that's to the debugger. This is a new watch point, even though to us it's like, well, that doesn't really seem to make a whole lot of sense, right? But what we can do is to do something a little bit more fun. Okay, what do you think this is going to do? It will return a value that is going to go from 0 to 9, exactly, because random number is going to be a huge number, which we don't really need, right? We just need a number going from 0 up to the number of colors minus 1, because we count from 0. So this is a mechanism where you can use the modulus operator in order to come up with a number of the right range for the colors. Okay, so let's go ahead and do this. And it has a color watch point number 3, hardware watch point number 3, and when we continue execution, you can see now how those values are changing. Does that make any sense to you? In other words, if you look at the old value of random and look at the old value of random mod 10 as opposed to the new values, do they seem to relate? This is a, come on. When the old value of random number ends with a 2, the old value of random number mod 10 ends with a 2. Does that make sense since we're modding with 10? It does make sense. When it ends with 5, random number mod 10 is also 5. Does it make sense? I chose mod 10 for a reason, okay? Because division by 10 is pretty easy to figure out when we are displaying numbers in base 10. So, are there any questions about how to come up with your random hidden pattern?
You just gotta put those into the hidden array.
Yep, you just have to put it into the hidden array inside the structure. Okay, so this is not just any hidden array, it is the hidden member of a game structure. All right, so next question. Next question is, but is it coming up with the same sequence of random numbers over and over again? Well, let's find out whether that is the case or not. So what we'll do is we'll set up the watch point first. So this time we'll set up random number mod 10, okay? Ambiguous, okay, watch. Here we go. Oh, because I have to stop the program first. B main, run the program. Once it stops, then we can set up the watch point. So we'll say watch random number mod 10. Here we go. And we'll just say continue. Old value is -9. That's because it's uninitialized. Okay, so it's 3, 6, 7. Okay, 3, 6, 7 is the first 3 numbers for this run of main. We'll quit the debugger altogether, get back in, put a breakpoint into main, run the program, and I can delete the breakpoint at this point and just add a watch point instead, which is random number mod 10, and say continue. 3, 6, 7. So we got the same 3 numbers back, when we have 2 separate and completely independent run of the same program. This is not an exact proof, but it is going to give us enough confidence that it will give us the same sequence of random numbers. Are there any questions about this part? I think for debugging purposes, you might even want to doctor the generate hidden part of your program initially, at least, to give it a fixed pattern. Not even rely on random number. Just give it a fixed pattern, just so they can debug the rest of the program first. Is that okay so far? Are there any questions related to this new homework assignment, other than the random number thing, which is just illustrated? Yep.
Yeah, you said the Makefile, we have to, for the Makefile, we have to add the additional things to the Makefile.
Yes. So I will briefly talk about that. Okay, I'm assuming you're using a Makefile already. Okay, so let me ask the other question first, because if they're related, I can answer both. Go ahead.
So, do we have to turn that a random number into a int after we've done all that on the long end?
No, it is already an integer to begin with. Okay. So random returns an integer to begin with, and you have to mod it to get it to the range that we want. And that's already an integer, so you can store it as an integer automatically. You don't need to do anything with it. Okay, so the answer to the Makefile question. Okay, so if you go back to the previous homework assignment, the one that was due this morning, so let me open it as a new tab. How many people actually made use of the Makefile? Okay, the majority of the class. Very good. Was it easy to use?
Save a lot of time.
Yep. And a lot of headaches too. It's not just time, because it makes sure that you are using the most up-to-date object files and executable for debugging purposes. For those of you who don't think this is going to save you time, you can just not use the Makefile, and basically just experience the kind of problems they can run into. Okay, so we'll save the Makefile into the 10 folder and take a look over here. Okay, so here is the current Makefile for the current homework assignment. How do you think should be changed here? What do you think this needs to be changed in order to make it work for the new homework assignment?
Just have to add the
You just have to add mmgame.cpp, and where do we add? Which line you're going to add it to? Line 7, CC source. Yep. That's all you need to do. That's why we like Makefiles, because you just go here and you say mm-game.cpp, assuming you have that source file already. That's all you need to do. But what about mm-game.h? That's a new header file. It's automatically figured out by the rest of the Makefile. That is why this Makefile is so useful, is because it figures out the interdependency of header files without you having to spell it out. So does that answer the question regarding the header files? Okay. All right, you're most welcome. All right. Are there any other questions related to this new homework assignment? Wow, this number jumped up from, I think it was 19, like when I left my office, it was at 19, and then now it's up to 21. So 2 people kind of turned it in, close to last minute. Okay, are there any questions about the new one? Mastermind playing, not scoring. No questions. Yep, go ahead.
In the main program, you specify using mmRead and mmPrintScore. What file do we include those step routines?
Those will be pound included into by mm.h.
Okay.
But you don't have to do a mm.h pound include explicitly, because mmgame.h is already pound including mm.h.
Okay.
It doesn't hurt to do it yourself if you want to add a new line in main. I'm not going to grade main.cpp, so you can do whatever modification you want to it. But it's not necessary to do it because mmgame.h already has pound include mm.h, which includes the prototype of mmRead and also mmPrintScore.
Okay.
And those are all recycled from the homework assignment that was due about 45 minutes ago.
Yeah.
Yeah. And I will talk about that too. So for people who want to kind of use my code instead of their own code, that's okay with me as well. The new homework assignment counts for, I think, 70 points instead of 50 points. The one that was due today was 50 points. This one is 70 points. But in terms of difficulty, this one is worth about 25 or so. So I'm kind of giving you guys a good opportunity to make up for points that you might have lost in the past, because this is actually a easier homework assignment. From the perspective of algorithm, this is actually easier. Is that making any sense that this one is actually easier? Because what is the complexity of this particular homework assignment? Okay, let's figure this out. Is this function difficult to write? I'm just going to reset a counter, which is a member of a structure pointed to by the parameter. It's a one-liner. Okay. What about the next one here? This guy here. But you know how to read into a whole hidden array already from the previous homework assignment in mmRead, right? This one is easier because you're not reading anything. You're not going to do any scanf. You're going to use random, which I just illustrated. Okay, so it's not going to be that complicated. What about mmRead? It's from the last homework assignment, and I'm going to talk about it during the lab time. So if anyone said, well, but I didn't quite finish the last homework assignment, will I be at a disadvantage? The answer is no, absolutely no, because you can borrow my code. What about mmGameGuess? This is the complicated subroutine of this particular homework assignment. But what do you do inside mmGameGuess? A few things. First, you have to call mmScore from the homework assignment that was due 45 minutes ago, which I will do again during the lab time, that you can borrow. Okay, that's not too difficult. 2, you have to update the counter. And well, between that, you also have to store the guess into the array that is into the guesses array of the structure, of the game structure. Would that be difficult? I'm trying to copy a structure to another structure. The first one is pointed to by a parameter. The second one is a member of an array, which is a member of the other structure. Would that be difficult? How many lines would that take? Yes.
Really?
If one side is a structure, the other side is a structure, a single assignment will do it. Assuming they're the same kind of structure, obviously. Okay, so that's a big clue of how to get this done. And then the third thing is to increment the counter. Okay, how many times has the end user guessed the pattern? That's a one-liner as well, right? So that means this part can be done with how many lines? Score, copy, and increment the counter. But you still have to kind of figure out, okay, has the end user used up all the possible guesses already? That's a conditional statement, right? And then you also have to take a look at the result of the scoring and say, well, is the end user guessing the actual pattern? That's another conditional statement. So I would say this particular subroutine has no more than 20 lines, okay? About 20 lines, depending on how you sprinkle your source code, you might be exceeding 20 lines a little bit, but it's not complicated. Will game guess include any type of loops? Okay, I'll leave the answer to you. Okay, I'm just asking that question. Are we just doing things sequentially and have to use conditional statements to decide which way to go, or do we have to do something repeatedly in game guess itself? Okay, not counting its subroutines, in just game guess itself. So you kind of have to figure that out yourself as well. And then print score is something that we have done already. Yep.
Can we just go through the how to set up it? I just confused how to set up the setup.
I can show you a simulation of how the game would go. Okay, so we can do that part. So I'm gonna use a mouse pad here. Oops. Well, VI works too, but it's not using the right font size. So I'm just gonna go back to mouse pad. And okay, so one part of this is not a part of the actual output of your program, which is the hidden pattern. Okay, so what do you guys want to use as a hidden pattern? It's up to you. Doesn't matter to me. 0, 1, 2, 3. Okay, or maybe 0, 5. 0, 5, 3, 3 is the actual hidden pattern. Is that okay? All right. So the first thing your program is going to do is to ask the end user to enter a particular guess. Is that okay? So I'm going to use user with a greater than here, just to indicate this is the user input, okay? Just so that I can differentiate between the user input as opposed to the output of the program. Your program is not supposed to prompt with user greater than in your program. Is that okay? So your program should behave the same way as your previous program and not to prompt anything. So the user, which is me, going to enter 1, 2, 3, 4 with spaces in between to separate the digits, and then press the enter key. Okay. The system will take 1, 2, 3, 4, and first of all, it will compare this. It will first try to identify: do I have any more guesses at this point? I have 8 guesses to begin with. This is my first, so that means yes, I do have room for one more guess, and then it will go ahead and decide to score it. What should be the proper score of this one? 1 black and 0 white. Okay, that's it. Okay, so the program is going to give me on one line, it will print a 1, which is the number of black pegs, and then on the other line, it will print the number of white pegs, which is 0. Then it will ask me again, excuse me, the program will print one more thing, which is, no, this is it. This is all it's going to print. So it is now my turn to input again, because it is not telling me try again or congratulations, I've done it. So now we have to enter a different guess. Okay, I don't have to really play it the way that I would normally play it. I can just do some random stuff here. So I can say 3, 3, 2, 2. Okay, 3, 3, 2, 1, which is not really even reasonable. So the program will still, first compare to figure out, okay, this is your second guess. Do we have room for a second guess? Yes, okay, because I am allowed up to 8 guesses. So then they will go ahead and score it, put it into the array, and then it will increment the counter. When game guess returns, then it will print out the actual score of this particular guess. And what should be the score for this one? How many black pegs should I get?
0.
0. And how many white pegs should I get? I should get, come on.
2.
2 is the correct answer because the 2 3s are all correct in terms of color, but they're both off in terms of location. Okay, then this is my third guess. My third guess is, okay, let's say, for whatever magical reason, I figure out the actual pattern on my third guess. Okay, so what the program is going to do is to go through the same motion. Okay, it will first check, is this my, am I going past my 8th guess already? No, this is my third guess. And then it will go ahead and score it. It will score, and it will put it into the array, and then it will decide, okay, is this correct? And since it is correct, it will not go ahead and print me 4 black pegs and 0 white pegs, because that is the body of the loop. I will have exited the loop already because game guess would have returned a value of 1 in this case. Is that okay? Okay, if we go back to the program, okay, let me just kind of go back to the program here. You can see that this is what is actually determining whether the program is exiting or not. Is game guess has to return a 0 for me to print the actual score. But when my guess is correct, game guess is going to return a 1, which will kick me out of the loop right away. So that's why I'm not going to print the score. Instead, I will go on to line 15, and since result is 1 in this case, the way the program is going to behave is just to print good job, and that's it, and the program exits. Do we have any questions about this particular run? Any questions about this one? No? Okay. So let's go for another one that is a little bit more mundane, and I'm still keeping 0533 as my hidden pattern here. So this one is rather boring because I'm going to use the same thing over and over again. First, second, third, fourth, fifth, sixth, seventh, eighth. Okay? Now after the 8th guess, it will still prompt me 1 more time. Okay, which is not exactly the correct behavior, but that's how the main program is written. Okay? But after I press the enter key, it will try to put this last guess into the system. But before it does that, it will say, okay, do we still have room for 1 more guess? No, we do not, because this is actually the 9th guess at this point. So the system will come back with a value of 2. Okay, game guess will return a value of 2, which will send me to, which will get me out of this loop, and it will get to the result equals to 2 here, and the program will just print try again. And that's it. That's how this program is going to terminate. Now, let me just double check on this one to make sure that we do have the right number of guesses here. So 1, 2, 3, 4, 5, 6, 7, 8. This is the 9th one. So it will prompt you for the 9th guess, but it's not going to process it. Okay. Are we doing okay so far with the simulation of this program?
Awesome.
Is that okay? Okay. Any other questions? There's no need to do error checking on this one. So if I were to enter something like this, for debugging purposes, you might want to do this. Okay. So for debugging purposes, you may not want to do it like 1, 2, 3, 4 all the time. So you might have 1, and then 2, 3, 4, 5, 6, 7, 8, and 9. So this is easier for you to count because you can look at each one and figure out, okay, what is the number of this particular guess? Okay, and it should still work. Unless you do something really funky with score in the current homework assignment. Because I know some of you, are kind of tricky and go like, hey, but I can I can change the peg to something that is not valid within the right color range to indicate it has been matched already. Okay, so if you use that approach instead of using an array to keep track of which one has been matched already explicitly, this may not work well with your program. Did you do it that way?
Yeah.
Did you use negative numbers?
I think I made it, because you know how we had the variable that was like how large our range is?
Yeah.
I made it
Plus one and plus two.
plus 1, plus 2, so that it wouldn't ever be in the range.
Well, you can change your program. I mean, you don't have to reuse exactly the same code as what you turned in this time.
Yeah.
So you can, knowing this is one thing that you can do. I'm not going to feed this as a pattern to your program. So if you decide that you're not going to test your program this way, you don't have to make a change, because we can make the assumption that input is always valid. Okay? But I'm just saying that for those of you who did not use that approach, you can use this to kind of keep track of the number of counting, so you don't have to like actually do the auto counting on the terminal. Are there any other questions about this program? Yep.
So should game call upon score within itself?
Game guess should call score. In fact, once you know that you have at least one more guess available, that's the first thing it has to do. Okay? Are there any questions about this? Questions? All right. So with this one out of the way, which is your current homework assignment, this one is due a week from today, which I think gives us enough time for another homework assignment before the end of the class, before the end of the semester. So I am attempting to use, to reverse the roles of the end user and the program as your last homework assignment, which is to let the program do all the guessing, and you are the one who is hiding the pattern. Okay? Now, how would you write a program to do that?
This is the next one.
That would be the next one, yes. But you should start to think about it early, okay? Because that one is a little bit tricky in a way, but a little bit not so tricky in a way. Okay, so how would you do it? If you are to reverse the roles, so you are the one who's hiding a pattern, so you say, haha, the computer probably cannot guess this one, 3, 2, 1, 5, okay? And the computer is the one that is saying, okay, is the pattern 0, 0, 0, 0? And then you have to score it. The computer will read your score and say, okay, let me come up with the next one. And based on the score of the next one, it will come up with the next guess, and so on. How would you write a program like that? You don't have to make it optimal, which means you don't have to make it so that it will use the least number of guesses, but it will still have to be reasonable, okay? In other words, you cannot use the exhaustive approach where it goes from 0, 0, 0, 0 to 0, 0, 0, 1, even though the feedback has no black pegs nor white pegs. Is that making any sense? Okay, so how would you do it? And I can give you a hint already. The approach is called generate and test. So what am I generating and what am I testing? I can use the whiteboard for this purpose. Well, yeah, the whiteboard is probably better. Okay, so the generating part is the pattern, okay? 0, 0, 0, 0, okay? The next one is 0, 0, 0, 1. The next one is 0, 0, 0, 2. And then all the way up to 0, 0, 0, 5, assuming that there are 6 colors, okay? But I can change the number of colors by changing mm.h, so that would be an easy one for me to change. The next one is going to be 0, 0, 0, 1, 0, which is kind of like a basic 6 number here. 0, 0, 1, 1, 0, 0, 1, 2, and so on. So this is a generate part of how the computer can say, okay, let me see what patterns are available. But you don't want to go for just for the next one and the next one and the next one, because this will have how many patterns are there when we have 4 positions and 6 colors?
4 to the 4th power.
2,000 something.
The other way around, 6 to the power of 4. Because each position has 6 choices,
Oh.
and then we have 4 positions, and each one is independent to the other positions. So that's a fairly large number, and you would not want to play this game with a computer when the computer keeps asking you, is it 0002? No. Okay, so that would make the game very boring for you as well. So you definitely don't want to do it this way. So this is the generate part. We'll talk about how to generate these patterns. So what you want to do is to test. In other words, you look at each pattern and you compare that to the guesses that has been done already, and based on the scoring of past guesses, is it reasonable that the actual hidden pattern is 0000? In other words, you're asking, if the hidden pattern was 0000, would it have given me the history of guesses and scores that I have gotten up to this point? That is the testing part. Is that making any sense or not? Okay? And the more guesses you have done so far, the filtering is going to work better, because a lot of these choices, a lot of the patterns that you can easily generate will not pass the tests. So you're basically reducing the number of possible patterns by the test process. Now the first one that it does pass all the tests, you can make it your next guess, which is not optimal, but nonetheless it is actually pretty good already for the purposes of this class. So this is the generate and test method of figuring out the solution of a problem, which sounds really brute force, right? Because we are basically we're generating all the possible cases, and then we are just testing to see which one can be the solution. But do you think this is a dirty approach, or do you think this is an approach that a lot of computer science problems are solved? The brute force, generate approach is actually how a lot of problems are solved. And since we have been talking about security and stuff like that, I'll just kind of give you a context of something like this. Okay. In computer science, particularly in computer security, there is such a concept called a rainbow table. Okay. Can anyone guess what a rainbow table is? It has 7 colors. No, that's not what it is. Okay, so I'll just go ahead and press the enter key, go to the first link. Well, in fact, I don't even have to go to the link at all. A rainbow table is a pre-computed table for reversing cryptographic hash functions, usually for cracking password hashes. Tables are usually used in recovering a plain text password up to a certain length consisting of limited set of characters. Now, given the context that we are dealing with cisp360 at this point, a lot of these things don't make any sense. What is a hash function? Well, all it is it maps a string to a particular big number. That's all it is. Okay? It suffices to say, this is how it works. With most Linux systems and most of your password systems, they do not store the actual password. In other words, the next time you log into Google or log into Facebook or something like that, think about how your password is actually stored on the other side. Okay, and one thing they definitely do not do is to store your password in plain text in some kind of a database. Why do you think that is not a good idea? Because if people get into the database, they get your actual password, right? Which is definitely not a good idea. Okay, so how do they store your password then? They have to store your password where it is not quote unquote reversible. In other words, once people, even if they can hack into the system and see how your password is stored, they should still not be able to figure out what to type to log in as you. Am I making any sense? So this way, even if the database is compromised, okay, the chances of people being able to log in as you will still be somewhat limited. That's the whole purpose. And this is how the Linux system deals with this problem. The way the Linux system deals with this problem is it has a file called shadow, and in shadow we have strange patterns. Okay, so let me turn off the syntax highlighting here. There we go. So we have like a really strange pattern. So the root has a password, That's not my password. That is the hash, the result of a hash function on the actual password itself. So now that you know that the hash function of my password as root, as the administrator of the system, you still cannot really figure out what to type when you try to log in as root on this computer, which is actually no big secret because this is a live distribution, and I actually tell people what the password is. So it's no big deal if you even can look it up and go like, oh, so your actual password is blah, blah, blah. It's not a big deal. But if someone is to hack into this system and find a shadow file, this is not helpful. Is that making any sense? Because the way we map the actual password to the hash function makes it difficult to reverse. Looking at this pattern, you cannot reverse it back into the actual password itself, and as a result, even if this file is compromised, the chances of someone trying to log in as root on this particular system is pretty slim. Until the rainbow table comes along. Okay? So if you look up the term rainbow table in Wikipedia, which has a pretty long page on this topic, it's a pre-computed table for reversing cryptographic hash functions. So what that means is somebody is using brute force to compute a string that can map to any hash value. Okay, and you can kind of imagine, all the total number of hash values is going to be huge. It's going to be a big, huge table. But somebody actually spent the time, use enough processing resources to basically randomly generate, text strings and say, oh, so this text string will generate a hash value of that. Store that into the table, move on to the next string. This string will generate a hash value like that, put it into the table. And you can imagine the table is going to be huge, right? In fact, this probably has a size limit here. Okay, so although the pre-computed hash chains, defense, common uses. So I'm just trying to find out the magnitude of the table itself.
How does it know the hash value of the string it enters?
Sorry?
How does it know what the hash value is?
Because the hash function itself is published.
So it can put in like 1, 2, and then
You can basically guesstimate. You can basically say, okay, I'll give you an idea. Okay. In fact, I'm just going to show you how it is done. So I will just go ahead and well, this will be okay. I'm just going to assign a new password to the end user, okay? And I'm just going to use 1234 as the password, okay? It does not echo the password because it's Linux, but I use 1234 as the password. So if I go back into Shadow and look up user, this is the hash value. Oops, sorry about the syntax highlighting here. But this is the hash value corresponding to the string 1234. So next one I'm going to try 1235, 1236, and so on. And each time I change the string, it will give me probably a new entry, a new value for the hash function. But there are only so many hash functions, hash values. So eventually, after a long, long, long time, I would have a table that has a string mapping to a particular hash value. But once I have that table, looking back, if I know the hash value, I just have to use that. I can use that table to look up to a particular string that will match it. That's how your password is working when you're logging into a system. Is they're not remembering your actual password, they only remember the hash value of the password. So when you log in again, you type in your password, it will compute the hash value of what you just typed and match it against the hash value that is stored in the table. If it matches, then you can sign in. If it does not match, you cannot sign in. But the problem is there are different strings of the same hash value. So sometimes they do not need to know your exact password. They just need another string that has the same hash value. That is how rainbow tables work. Question?
Is this why it's such a big deal when you hear people talking about certain companies storing passwords in plain text?
That would
They should
be
storing it as a hash.
storing password in plain text would be exceedingly irresponsible. I wouldn't call it dumb or stupid, but I would call it irresponsible because by any standard today, people can look up and say, okay, store password in plain text, just do a Google search, and there'll be like tons of articles saying why it is not a good idea. So no one should be storing password in plain text at all.
I've heard some scandals of companies doing that.
Because they did not spend the time to do security auditing and to make sure that things are actually secure. Even with hash function, if it is not what we call salted and based on MD5, it is still insecure because of rainbow tables.
65 trillion.
65 trillion, which
Yeah.
sounds like a lot of numbers,
It's
but
the
these
standard,
days,
yeah,
okay.
for standard passwords.
65 trillion. Okay, so let's take a look at these numbers here. 65 trillion. Okay, which is 65 followed by how many zeros in base 10? A trillion is 12 zeros, right? So 65 times 10 to the power of 12, which sounds like, wow, that is a pretty big number. What kind of hard drive can you buy at Fry's these days? If I give you like $150 and say, okay, buy me the largest possible hard drive for that money at Fry's, $150. What kind of a hard drive can I buy? Let's look it up. If you don't know, we're sitting right in front of a computer, so we'll just look it up, right? Frys.com, and we'll look up hard drives. And we'll look up internal hard drives, and I think there has to be a way to use the money. Yep, use price as a criteria. 120, 150, $150 right there. I personally would not buy another Hitachi hard drive, but here it is. 3 terabyte. Okay, so 3 terabyte is what is 1 tera? T-E-R-R-A. T-E-R-A. Sorry. 1 tera is 1 trillion. Okay, so this one hard drive that I can buy for $150, which is not a whole lot of money, can store 3 trillion bytes. Okay, how many bytes do you think I would need to store a MD5 hash? Does your number quote the number of bytes needed? No.
I looked up a calculator. So.
Okay. Let's say 256 bytes, okay, which is more than what is actually needed to store one entry, okay? So you just say, okay, what is this number times 256? To make it easy, I'm just going to say times 1,000, okay? So each hash entry is going to take 1 kilobyte-ish, okay? So what this is going to do is to change the magnitude by this. So now I need 65 times 10 to the power of 15 number of bytes in order to store the rainbow table. Do you think this is doable? If I'm a hacker and the payoff of being able to break into a system is in millions of bucks, okay? Do you think buying like 20, 30 of these hard drives is going to be a problem for me?
Yes.
No. In fact, I'm not even going to buy anything. All I'm going to do is to go to Amazon, AWS, Amazon Web Service, and just pay top money to buy a virtual machine with a lot of processing power and a huge amount of storage. Okay, so I'm not even going to set up my own computer to do this. I'm just going to the cloud and say, hey, give me a 20-core setup with 16 gigs of RAM and whatever amount of storage I would actually need to do this. Okay, run that job, pay probably, I don't know, $20,000, $30,000 ish. Okay, to get the job done. Download the whole rainbow table. Now I can hack into any system where the hash value of passwords are already known. And as a hacker, it's the payoff that counts, right? I may be spending $20,000, $30,000 to get my rainbow table, but if the payoff is in millions of dollars, that's an easy number. It's an easy decision to make, right? That is why it is practical now, because even though 65 times 10 to the power 15 sounds like a huge number, it is entirely doable these days. Okay, so this has to do with the amount of processing power that we have and also the amount of storage that we have today. 20 years ago, people look at this number and go like, well, you can do it, but it's not practical to do it because the amount of processing power and also storage to do this will be in the national budget level. And we are not talking about small countries either. We're talking about big countries, and only big countries can do something like this back 20 years ago. Now, you can probably do it. I mean, if you go to the bank and get a loan, you just have to convince the bank to loan you like $20,000, $30,000. So you can run that job, using AWS and get your rainbow table. And that's why MD5 is not considered secure by today's standards. 20 years ago, absolutely, it's good. But today, not so good.
How do you make money by hacking?
There are different ways to do it. Some people would blackmail companies and basically say they would hack into the system first using the rainbow table and using the known hash table. They will be able to log in and they will slurp all the data back. Okay, so they will have a copy of the entire database. Okay, so if you're talking about banks, HMOs, health management organizations, and stuff like that, it's a big scandal. So a lot of times, what these hackers do, or we call those people black hats, is they would do the hacking. They would basically download the entire database, and then they would blackmail these organizations and say, hey, if you don't pay us blah 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 this much money, we are going to tell the entire world that we have your database. And sometimes they just pay off and say, okay, don't tell anyone. So that's one way these hackers or crackers can make money, and sometimes they sell that information to other people, which is even more profitable because now you can sell the same information 20 times, 20,000 times, 200 million times, and each time you sell it, it's still money. Yep.
You can make a lot of money with bounties now, right? Companies will pay you to find bugs and stuff, and weaknesses.
I do not know, about the whole legal thing about hacking and cracking, but it's a difficult thing to fight. Okay, from the legal perspective, it's actually very difficult to fight because a lot of times, the black hats, the crackers, people who are doing this, are not in this country. So the FBI cannot touch them because they're not in the United States. So you have to rely on Interpol and some other international organizations to nab these guys. And it's not going to be easy, depending on where they are actually located. Any other questions? You guys don't seem very, interested in all these topics here. But it is actually related to everything that you will be experiencing in the next 10, 20 years. Hacking is not going to taper off anytime soon. It will only continue to grow, I would say, almost exponentially. Okay, people will find new ways to hack into systems and so on. So all organizations really need to think like 10 years ahead of time, just to keep up, just to make sure that they are not the weakest link of the entire system. Any other questions? So this is not the reason why I want you guys to do the mastermind program though. But you guys get the general idea, right? I mean, it is kind of like that, okay? And then some people might complain and say, but Tack, you're teaching your students how to hack. Which I am, but is it a bad thing? Because if hacking is not exposed to people, then people don't understand the importance of the white hats, the people who are going to catch the black hats. Okay, and I think in the United States there are not enough security experts, and we are basically will be in shortage of security experts for the foreseeable future. Okay. So that's why, for those of you who are interested in these topics, this is a good area to get into. Not the blackmailing part, okay, but the nabbing of the bad guy part, okay. That's actually a pretty good occupation to get into because of job security for one, pay scale is good, okay, and three, it is challenging. This is not going to be a boring job where you sit, behind a computer and just, make new SQL queries, every single day. This is going to be exciting because you have to respond to how people attack your system.
there such a shortage of white hats because so many potential white hats end up becoming black hats?
No, it's not exactly because of that. It mostly has to do with just population. It's just a sheer population thing. In some countries that are known to attempt to hack and successfully did so to United States systems, the population is in the order of 1.7, 1.8 billion. And there are at least 2 countries of that size, right? And there are numerous other countries that are smaller, but together, collectively speaking, they still have a lot of people. The population in the United States is what, 300 million or so, in terms of order of magnitude. So with 300 million people, and let's say 3 billion people on the other side, the equation is not favorable, because in this case, the more people definitely helps. It's not like when you're dealing with actual physical weapon, where one super duper superior weapon can take out or is equivalent to 100 of the inferior weapon. In this case, all you need is someone who is well trained, okay, who has the know-how and a computer. You don't need the fastest computer to do most of the hacking either. So the more people doing it, obviously the better. And as a result, a 10-to-1 ratio in terms of just sheer population size is going to place the United States at a slight disadvantage. Is that?
Yeah.
Yep.
That puts it in perspective.
Yep. So I'm going to stop the lecture now. We'll take a little 10-minute break, so we'll come back at about 10:37, and then we'll talk about the solution of the score, the mastermind scoring program, as a solution. Even if you got it, you can still kind of stay so that you can compare your solution to mine.